The last conic section we're going to look at is a hyperbola. Let's look at a definition. A hyperbola is the collection of points in the plane, the difference of whose distances from two fixed points, called the foci, is a constant. To help you understand this definition, let's look at a picture. We have that the distance from F1 to a point on the hyperbola minus the distance from the point on the hyperbola to the other point is a constant. In this particular graph, we have the center labeled. There are two vertices and two foci. The axis that travels through the center, the vertices, and the foci is called the transverse axis. The axis that is parallel to the transverse axis that travels through the center is called the conjugate axis. Let's look at the equation of a hyperbola whose center is at the origin and has a transverse axis along the x-axis. An equation of the hyperbola with center at the origin that has foci at negative c comma 0 and c comma 0 and vertices at negative a comma 0 and a comma 0 is given by x squared over a squared minus y squared over b squared equals 1, where b squared equals c squared minus a squared. The transverse axis is the x-axis. To help you visualize this equation, let's give you a graph. What we have drawn here is a hyperbola that opens to the right and opens to the left. You should see the transverse axis is labeled as the x-axis. The center of the hyperbola is labeled at the origin. I have two vertices, one located at a comma 0 and the other located at negative a comma 0. The two foci are located at c comma 0 and negative c comma 0. The thing to be aware of in hyperbolas is that there is no relationship between a and b. A could be larger than b, a could be less than b. The trick in determining whether the hyperbola opens left and right or up and down is which term is first in the equation. When the x squared is first in the equation, the hyperbola will open to the right and to the left. Notice also the relationship between a, b, and c. It's now the case that b squared equals c squared minus a squared. Contrast that with an ellipse where b squared equals a squared minus c squared. Make sure you're aware of this difference. Now let's go ahead and do an example. We're given the center of the hyperbola is at the origin. We have one focus at 3 comma 0 and a vertex at negative 2 comma 0. To help visualize what's going on here, it's helpful to draw a little picture. I have my center at the origin. I have a focus at 3 comma 0. I have a vertex at negative 2 comma 0. We should see, based on this graph, that I'm going to have a hyperbola that opens to the left and opens to the right. Because of that, I know that the equation of the hyperbola is going to be x squared over a squared minus y squared over b squared equals 1. A is the distance from the center of the hyperbola to one of the vertices. C is the distance from the center of the hyperbola to one of the foci. Based on that, we can see that one of the values of A is 2 and the value of C is 3. We can find the value of B simply by using the fact that B squared equals C squared minus A squared. Well, that means that B squared equals 3 squared, or 9, minus 2 squared, or 4. 9 minus 4 is 5. Therefore, B equals plus or minus the square root of 5. Based on this information, we know that the equation of the hyperbola is going to be x squared over a squared, or 4, minus y squared over b squared, or 5, equals 1. Again, notice that a does not have to be larger than b in a hyperbola. Where are our focus going to be located at? We're going to have a focus at 3, 0 and at negative 3, 0. Vertices at negative 2, 0 and positive 2, 0. Let's use this information to start up our graph. We're going to have our graph whose center is at the origin. We have one vertex at 2, 0. We have another vertex at negative 2, 0. Why? Because A was found to be 2, and A is the distance from the center to the vertex. We knew we were going right and left because of the fact that the hyperbola were opening to the right and the left. Similarly, we can find the foci to be located at 3, 0 and at negative 3, 0, because C was found to be 3, and 3 is the distance from the center to the foci. Now, the problem is we have no idea at all how wide to make the opening. To help us determine this, what we're going to do is use the equation and find points above and below the foci. I'm going to find points above and below the foci by letting x equal plus or minus 3 in the equation. So here we go. We're going to have plus or minus 3 squared over 4 minus y squared over 5 equals 1. That gives me 9/4 minus y squared over 5 equals 1. Subtract 9/4 from both sides of the equation. We get that, well, I can just jump over to y squared over 5 equals, that would equal 5/4. Multiply both sides by 5. We get y squared equals 25/4. So y is going to equal plus or minus 5/2. So at 3, 0, I'm going to have a point up here above that at 3, 5/2 on the graph. So 3, 5/2. I'm also going to have a point at 3, negative 5/2. 3, negative 5/2. I also let x equal negative 3, so I have a point at negative 3, 5/2. And I have a point at negative 3, negative 5/2. So negative 3, negative 5/2. I use all these points to graph in my hyperbola. So I go through that point, and I go through that point. I'm at my vertex, I go through that point, and I go through that point. These points assist me in determining the opening of the hyperbola.